This video is all about how to use your puzzle cube solution, which we'll also refer to a lot of times as a three-plane explosion. It consists of a few different things: constraints, criteria, which are like your directions, two different examples of how pieces could be put together using numbers, a third example where you'll fill in the numbers, and beside it, a fourth example where you'll fill in more numbers. For this, example 3 is my solution 1, and this example over here on the right is my solution 2. Over here you'll find that I do some math to help numerically explain the process that I go through in some cases. Let's start with our criteria. You're going to use numbers 1 through 5, and you're going to place those numbers for the various different parts on the front of the grids. Don't place them on the top or on the right. The numbered squares have to touch like numbered squares, either above, below, or on the planes in front or behind. For example, this number 3 touches another 3 to the left of it, but it also touches a number 3 on the plane behind it, and that 3 touches 1 below it. All parts have to meet all the constraints. I have to make at least 2 solutions, but I'm welcome to make more than 2 if I print out another sheet. Make as many as you want. Then I'm going to cut out all of what these criteria say. I'm going to cut out both solutions, and I'm going to cut out my constraints. I also recommend to you to record this information and place those cutouts and that recorded information in your engineering notebook. Let's look at the constraints. Each solution has to have 5 parts, no more, no less. Each part must consist of 4, 5, 6, or 7 pieces. Each part must have 2 to 3 pieces in the height, the width, and the depth direction. For example, part number 1. There's this one, then this one. That's 2 units in height, or 2 pieces in height. There's this one, that's 2 pieces in width. And then I have a third one back here. That's at least 2 pieces in depth. Now this one goes on to also have a third piece in width. And it has this piece, or excuse me, a third piece in depth. And it has this piece, which is still only 2 pieces in width. Even though I have this one and this one, those two ones go the same distance. And even though I have 2 units here, or 2 pieces here in height, these two are the same amount. But I do meet my third constraint with that. Only 2 by 2 piece slabs, and only one of them per solution, and no double slabs. For example, these 3s are set up so that there's 2 by 2 of them, giving me 4 pieces that all touch together. That's a slab. Now, if this 4 were a 2, then that would also be a slab. And I can't have that if I have the 3s as a slab. That would be 2 slabs. And I can't have a double slab. So, for example, if I had, let's say, this was a 3 and this was a 3, then I would have a slab on the top and a slab on the right, and that would be a double slab part, and I won't allow that. The other constraint, the final one, is that parts can be mirrored, but they cannot be duplicated. Now, the best way for me to explain this to you is if you think about your hands. Your hands are mirrored of each other. They're opposites. They're very, very similar, and in fact, they're probably identical, except for the fact that the left one is in a left-hand orientation, whereas the right one is in a right-hand orientation. If facing in the same direction, they're opposites. If facing each other, they're mirrors, meaning that they're opposite of each other. but they're never going to be the same part. If you have the same part, then you have a part that is duplicated. Parts that are duplicated are not allowed. Mirrored parts are okay. Duplicated parts are not allowed. You'll notice that the three planes are separated in the depth direction. And I've identified where the height is from top to bottom, bottom to top, the width from left to right, and the depth obviously from the front plane through to the back plane. It's up to you, the process that you go through, to decide where parts are, and for those parts where each piece is. But I do recommend to you that you think ahead, and by doing so you'll probably want to write in the piece numbers as you make the parts and keep track of them. See if they total 27. For example, if I start by knowing I'm going to use a 4, a 5, and a 6 piece part, that leaves me with 15 pieces that I've used, and I only used 3 parts. Well, if I have 27 total pieces that I need to use because I have a 3 by 3 by 3 cube, and I subtract 15 from that 27, I'm left with 12. And I have 2 parts left since I've only used 3 of them, so I need to have 2 more that are 6 pieces. And that leaves me with a 4, 5, 6, 6, 6. I could also use 3 5s, take 1 away from this last 6 down here and make it a 5, and add it to one of the other parts that was the 4. That gives me 3 5s, total of 15, 2 6s that are left. This solution is also good. 7 plus 6 is 13, plus 5 is 18, plus another 9 is 27. Same thing works out here, only in a different orientation. A 5 and a 7 is 12, and 6 is 18, and a 5 and a 4 is 9. 18 plus 9 is 27. Don't leave yourself stranded. If you're looking and seeing that one piece isn't going to touch anything else and you're not going to be able to meet all of these constraints, then don't move forward. Stop and solve that problem first. I wish you the best of luck in creating your 3-plane explosions and creating your 2 solutions.